Hi everybody, we're starting standards 10 through 13, all about parallel lines and a transversal. So here you see two parallel lines, the yellow ones here, and we know they're parallel because of these arrows right here. Those arrows, when you see arrows on lines, that means they're parallel to each other. Remember, parallel means they never ever touch. So this is line M right here, and line N right here. I see the M and N are parallel to each other because of the arrows on them. The purple line that's drawn on here is a transversal. A transversal is simply a line that intersects two or more lines, and it's named line T in this case. So this purple line here, that's our transversal because it intersects both line M and line N. And this is just some basics that you'll need for these four standards, and also standard 14 when we get to it. At the bottom of the page, if you ever see foldable, that means there is a box for it on your foldable that you can draw a picture in and put the definition on. So this is one of those boxes on your foldable. Okay, so standard 10 will be linear pair, vertical angles, and corresponding angles. First of all, linear pair, that should just be a review. Two angles that are adjacent to each other whose sum is 180 degrees. So for example, angles 1 and 2 here, two different angles, they're right next to each other and they form a line. So they add up to 180 degrees. 3 and 4, 1 and 3, 2 and 4, 5 and 7, 6 and 8, 7 and 8, 5 and 6. All of those are examples of linear pairs there. And remember, linear pairs always are supplementary because they always add up to 180 degrees. Vertical angles should also be a review. Angles that are opposite of each other when two lines are intersecting. So 1 and 4. Those are vertical angles. Those are across from each other. Vertical angles, remember, are always congruent. 2 and 3. 5 and 8. And 7 and 6. All of those are examples of vertical angles on this picture. Corresponding angles. Okay, so this is a new one. Notice it says foldable down here. So on your foldable, there's a spot for corresponding angles. You should have preferably 4 colors available, whether it be highlighters or crayons or colored pencils, so you can color code your paper like I did here. So again, we have line M and line N parallel to each other. When we have our two parallel lines and our transversal, then we can say we have corresponding angles that are congruent to each other. Corresponding angles are simply angles that are in the same spot. So 1 and 5, those are in the same spot. They're both above parallel lines and to the left of the transversal. 2 and 6, 2 and 6, those are corresponding angles. They're both above the parallel lines, but to the right of the transversal this time. 4 and 8, those are congruent. They're both below the parallel lines and to the right of the transversal. And finally, 7 and 3 are to the left of the transversal and both below the parallel lines. So as long as you have parallel lines, you can say that these corresponding angles are always congruent to each other. Besides the special names like corresponding, knowing the relationship is also really important. So corresponding angles are always congruent. So on your foldable, definitely color code things and also write your definition in there and write out this. What's congruent to what? Now, you don't have to only write on your foldable. If you also want these in your notes, feel free to write all this in your notes as well. Okay, we're moving on to standard 11, alternate interior angles and alternate exterior angles. Alternate interior angles, so alternate means opposite, interior means inside. So first we identify our parallel lines, lines M and N. inside. Interior means inside of our parallel lines, so we're looking at any of these angles inside, any of them inside of parallel lines. And alternate means the opposite side of the transversal. So 3 and 6, those are opposite sides of the transversal, and they're both inside. So angle 3 is congruent to angle 6. 5 and 4. 5 and 4, opposite sides of the transversal, both inside the parallel lines. So color code these on your foldable. Notice they're always congruent to each other. Make sure you write out definition and your examples. Okay, another one on your foldable, alternate exterior angles. Alternate exterior, so you're looking at outside of the parallel lines now. So outside of lines M and N. And then alternate, so opposite sides of the transversal. So 1 and 8. Those are both outside of the parallel lines, but they're on opposite sides of the transversal. Angle 8 is on the right side, angle 1 is on the left side. Alternate exterior angles are always congruent to each other. Angles 2 and 7, notice that 2, it is outside of the parallel lines, and it's to the right of the transversal. 7 is to the left of the transversal and outside of the parallel lines, so those two are congruent to each other as well. Moving on to standard 12, we have consecutive same side interior angles. So sometimes you'll see this as consecutive interior angles, sometimes you'll see same side interior angles. Same with consecutive exterior angles. Sometimes you'll see it as same side exterior angles. This one is another one that's supplementary. Okay, so if you're ever looking at same side or consecutive, those are supplementary angles. So when we look at same side interior, we're looking at inside. Interior means inside of our parallel line, so inside of M and N. And same side, so same side of the transversal now. So 3 and 5, those are both on the left side of the transversal and both inside of the parallel line. So those two, if you add them together, would get 180 degrees. Same with 4 and 6. If you added their measures together, you would get 180 degrees because they're both inside of the parallel lines and they're on the right side of the transversal. Another one you can be putting in your foldable, color coding, writing down definitions, and the examples here, giving you some concrete thing to look at. Then our second one for standard 12, consecutive or same side exterior angles. So now we're looking outside of our parallel lines. So 1 and 2 and 7 and 8, those are the angles outside of our parallel lines. Remember, same side, so both on the right side or both on the left side. So 2 and 8, those are both outside of the parallel line, so exterior. And they're both on the right side, so they're on the same side of the transversal. So angle 2 plus angle 8 equals 180 degrees. So consecutive same side or same side exterior angles are always supplementary. Angle 1 and angle 7, if you add those together, those will always equal 180 as well. So same side exterior angles, they're both on the left side of the transversal now, and they're both outside of the parallel lines. Standard 13 is simply a combination of standards 10 through 12. So you'll see more than just one problem or one angle you're trying to find in a picture. You'll have to use all of those. Maybe you'll have to use corresponding angles and alternate interior angles in the same problem. So standard 13 covers when you have to use more than one of those special angles formed by parallel lines. All of the examples that we'll do will be standard 13 examples, but obviously you'll use pieces from standards 10 through 12 to solve these problems. So our first example, we have to solve for angles 2 through 4, knowing that angle 1 equals 52 degrees. So I wrote out just one way to do it. Notice that there is not only one right way to do this. Now this is just the way that I chose to do it. So angle 1 plus angle 2, they're a linear pair. two angles that are right next to each other, adjacent, and they form a line between the two of them. There's that line right there. So I said angle 1 plus angle 2 equals 180 because it's a linear pair. I plugged in this 52 here, so 52 plus angle 2 equals 180. When I subtract 52 from each side, I know that angle 2 equals 128. So there's one of my answers. Angle 2 equals 128 degrees. Now that I have that information, I can see what angle 2 has a relationship. What other angle? I see here angle 2 and angle 3. Those are alternate interior angles. They're both inside of this parallel line and this parallel line. So if we're looking at the horizontal parallel lines, 2 and 3 are inside of them. This middle vertical line, that's my transversal, and that puts 2 and 3 opposite sides of the transversal, both inside the parallel lines, so alternate interior angles. So let's see if I can highlight this for you a little bit. Angles 2 and 3. So that's this angle right here. And this angle right here. Angles 2 and 3, those are alternate interior angles. So they equal each other. They're congruent to each other. So if angle 2 equals 128, then angle 3 has to be 128 as well. Then I move on. How do 3 and 4 relate to each other? 3 and 4, they're a linear pair. Two angles that are right next to each other or adjacent, and they make a line. Here's that line they make. So angle 3 and angle 4 equal 180 degrees. Let me add something. 180 degrees. And I plug in my 128 for angle 3 right here to get 128 plus angle 4 equals 180. When I subtract 128 from each side, I figure out that angle 4 equals 52 degrees. Now this makes sense to me because I know angle 1 and angle 4, those are actually alternate exterior angles. They are both on the outside of those horizontal lines and they're on opposite sides of the transversal. Alternate exterior angles should be congruent to each other. So we did figure out that angle 1 and angle 4 have the same measure, and that should be obvious to us because we see that they are alternate exterior angles. Like I said, more than one way to do this problem. Realizing that we have alternate exterior angles is one way to do that. Example 2. We have a 72 here. This is angle 1 right here. And then this is 2x, this bottom piece. Okay, so first I see angle 1 and 72, those are vertical angles, so that means angle 1 has to equal 72 degrees. Next I see that angle 1 and that 2x, they're consecutive or same side interior angles, so they are supplementary, they equal 180 degrees. I take that angle 1, that's 72, plug it in here, so 72 plus 2x equals 180. When I subtract 72 from each side, I get 2x equals 108 degrees. I divide by 2 to get x equals 54 degrees. Now, I see that I have parallel lines here. Because I saw those parallel lines, it was okay to say that consecutive or same side interior angles were supplementary. If you don't see those parallel lines marked, or if it doesn't tell you that you have parallel lines in the picture, then you won't have supplementary angles here, or you won't have the congruent angles like alternate interior, alternate exterior, corresponding those pieces. So you have to have parallel lines here. For example number 3, we have to find A and B. I'm given 102, the bottom left, angle A and 102, those are corresponding angles. So I have my parallel lines, both directions. And I see that 102 and A, those are corresponding angles with these to here. Those are my parallel lines, and then that more horizontal line there is my transversal. So 102 and A, those are corresponding angles. They're both in the same spot. So they equal each other. Then A and B, just looking at different parallel lines here. Now I'm looking at the more horizontal parallel lines. And then this right line would be my transversal. They're on the same spot, just looking above the parallel line each time. So above and to the right. Above the parallel lines to the right of the transversal. So they're corresponding angles. So A equals B, and that would mean that B also equals 102 degrees. As I said, there's more than one way to do most of these problems. It just kind of depends on what do you see. What's the best thing to work with here. Sometimes you'll have to write in new angle names, which is completely fine. Just got to get to angles A and B in the end. Okay, draw this picture, of course. I hope you've been drawing pictures as you've gone along, so you have your notes down. Okay, first thing I see, this triangle on the left, that's an isosceles triangle. I know that because of the tick marks. Tick marks, remember, that means they're congruent. Isosceles means we have two congruent sides on the triangle. And we've mentioned before that if we have two congruent sides, or an isosceles triangle, then the base angles are also congruent to each other. The base angles would be here, this angle A, and the 57 degrees. Now it's always a good idea to mark your picture. I'm just a little hesitant to do it while I'm giving you notes so that I don't cover anything up. So it's good to write in numbers as you find out more information. So for example, because I just solved angle A, I know it's 57 because base angles of an isosceles triangle are congruent, I would write in a 57 right here. Also, I'm using a computer pen, so that's not really easy. You probably can't even read my writing half the time. If I was using paper and pencil, I'd write that in right here. Next, angle A equals angle B because they're corresponding angles. So I have my parallel line here and here. Those are in the same spot. They're both to the left of the parallel line and above this transversal. Sometimes you'll have to extend the line so you can really see where the parallel lines are, where the transversal is. So I found out that angle B also equals 57 degrees. And that's it, and I'm done.